Okay, so you can talk all over it, doesn't matter. So just interact, it's just for anyone who's away or whatever, or you need to go back to it. Right, let's have a shifty at this. We've got, it's a running total, so you need to add up these numbers here and accumulate them. Okay, so how do we do that? It means how many people were less than or equal to, okay, less than or equal to 18. We use the upper categories of each category, the upper boundary of it. So less than or equal to 18, there were 3 people. Less than or equal to 21, there was 12 and 3, which means 15 in total. Those people who are less than or equal to 24 centimeters, or plants that are 24 centimeters in total, there was 35, 12 and 3. So add 35 to that, gives you 50. Less than or equal to 27, there's another 26, which now makes 76. And all of the plants that were less than or equal to 30, well, that's all of the plants, so it's another 4, which gives you 80. Okay, and if you add these all up, you can see that we've got 80. And if these two figures don't add up, then you've got a problem, you've done something wrong. Now, cumulative frequency, very roughly, looks like this. You have got one axis and another axis, and the vertical axis has always going to be, or is always going to be, cumulative frequency. And the upper end of this is this figure here, which is the entire survey. There was 80 plants surveyed, so I've got to go from 0 to 80. So I suggest every 2 squares is worth 10. 2 squares, 20. 2 squares, 30. So your vertical scale is always your cumulative frequency, CF. Your data always goes across here, so that's the data was height, and the data was measured in centimeters in brackets. That's going across there. Now I've got to start at 15 and finish at 30. So I'm going to jump from 0 all the way to 15. So I'm going to put a heartbeat in, a skip, and put in 15, and I'm going to suggest that shall I say 15 squares, yeah, I suggest every 5 squares is 5, so that's going to be 20. 5 squares is 25, 5 squares is 30, and that will do us. So data, always on the bottom. Sometimes we need a heartbeat to skip from 0 to there. Your vertical is always your cumulative frequency, and it needs to go to the amount of people you've got in the survey, or the amount of items. And all we do now is we write these two things here to remind us that at 18, the upper boundary, you plot 3. So at 18, you plot 3. At 21, we're now going to plot 15. At 24, we're now going to plot 50. Okay. At 27, we're going to plot 76. So 27, 76, and then finally at 30 we're going to plot 80. Now you can do it with a smooth curve, but there's nothing stopping us with doing it with a straight line. So connecting it with straight lines like such, and there you have your stretched out S. Okay, right. And if you wanted to, you don't have to, but some people look at the category down here and they draw it down to 0. Okay, and the reason you can do that is there's nothing full in this category, so you can join it down. But you don't need to, so I'm not going to. In fact, I never do it. I'm just saying that if you see it drawn down, you understand why it's drawn down. Okay, The next question is, so we've done the first bit there. The next thing is estimate the median and the interquartile range. Well, the median is found at the halfway along the data if it's an order of size. Well, these are in order of size from the lowest to the biggest. So median, as you know, can be located at halfway along your total data. Halfway of your 80 piece of data gives you 40th position. It is in the 40th position. So you need to get a pen out and a ruler. I'm changing the colour. And at 40, you would carefully draw a horizontal line. You would hit the curve, read down. Okay, and I tend to put arrows on the direction I've just read and label it as M for median. Now on my scale it looks, and mine's dodgy, remember it's on a, you know, I haven't got squares or anything like that. It looks like it's about 23. Okay, you put down whatever yours is. So therefore median height is, mine is 23 centimeters. Yours might be different and more accurate. And then finally it says work out an estimate for the interquartile range. Now to find the interquartile range, you've got to find out the lower quartile and the upper quartile. You've got to remove the bottom and remove the top, and you're left with the middle bit, the interquartile range. Okay, so first of all, IQR, this is part 2, that was part 1, and we're going to first of all find the lower quartile, and its position is found by a quarter of the way up of all of our data. All of our data is 80, so it is the 20th position. That's not the answer, it's just where we locate it. So in a different colour, I'm going to read off horizontally at 20. So I'm going to locate where it is, hit it, and read down. Okay. Put your arrows on, show which direction you're reading, and that is your LQ, your lower quartile. It is located at a height of 21, wherever yours says. Okay, so I'm just going to put mine down. So therefore LQ is equal to 21 centimeters. In a similar vein, we need to find the upper quartile. Now you can read 20 down, or you can just work out 3/4 of 80 gives you 60. 3/4 of 80 divided by 4 is 20, times by 3 is 60th. It is the 60th value. So we got to read off at 60. Okay. So just to finish this off, at 60 you hit your graph and you read down, and I make it to be 26, but that's just mine. Okay, so put an arrow on, and this is your upper quartile, and I'll finish it off by saying therefore UQ is equal to 26 centimeters. And then finally, therefore, the interquartile range is actually 26 centimeters, take away, in fact you don't need the centimeters, take away 21 gives you 5 centimeters. Now what does that tell us? What is the IQR all about? Well, the IQR is this gap here in your measures. Now out of 80 plants, understand what's being talked about, it's the height of a set of plants. 80 plants varied in height by 5 centimeters. 80, quite a few plants varied by something so small. So is this data consistent or inconsistent? Consistent. Okay, so therefore it would suggest the data is consistent. Okay, it doesn't vary much, and therefore any conclusions you draw from it are going to be pretty accurate. Okay, the median is going to be pretty accurate. Most plants are going to be around 23 centimeters tall, and they only vary by 5 centimeters. Okay, and just to remind me again, how much data is lying just there? 50%. Okay, 50%. 25% there and 20% there. Right. Now I'm going to mess around with this question just to extend it a little bit. Okay. Right. What they call them? Horticulturist? Is that the word? I don't know. But only wants the best plants, the biggest plants, and therefore they can't waste area of their greenhouses with small plants. So they are going to remove any plant that is smaller than 24 centimeters. Okay, how many plants are they left with? What's an estimate? What would I need to do? Any plant that is under 24 centimeters is going to be removed. So how many plants am I left with? Okay, how many plants will fit the bill of being over 24 centimeters? Right, what I do is I look at my centimeter gauge down here. I read off at 20. I'm going to change the color. Okay, and I get a pen here, and you would read up, and you'd hit your graph, okay, and you'd read across, and you would see that actually how many plants fell below. How many plants fell below? 50 plants. So how many plants fell above? 30. And if I asked you what fraction of the plants actually were bigger, what would I do? How would I set the fraction out? 30 plants out of 80, which cancels down to 3/8. And if I went a bit further and said, what's the percentage? What percentage of the plants am I left with that are actually successful? What would I need to do? Times by 100. Okay, so that question could go as far as that, and using your cumulative frequency, and that's how we do it. Right, that's cumulative frequency. Okay, underneath that, I want to put a quick note about the steepness, just to remind certain people. Okay, notes on CF graphs. Okay, so there's a couple of bullet points I want to bring out. Can connect coordinates with a curve or straight line. So you might see both in the exam, it doesn't matter, straight line. Okay. I want this next point written in capitals. Always plot using the upper underlined boundary of each class. Next bullet point, don't need to connect a graph down to horizontal axis. And lastly, expect graph to look like a stretched out S. Stretched out S. Okay. Outcomes underlined. Just one final note very quickly. height of that, they begin at the same and they end at the same. Okay, they begin at the same horizontal and they end at the same height, but they get there in different ways. The steeper the graph, as we said, there's your lower quartile, hit, come down. There's your upper quartile, hit, come down. Okay, so I'm going to make a quick note. Upper quartile, lower quartile, and that gap there is your interquartile range. That there would be your lower quartile. That there would be your upper quartile. And that gap there is your IQR. Steeper means more consistent data. Consistent data. Okay. Okay, so steeper means more consistent. Okay, I've got 10 minutes left. And I just want to remind, don't draw this out, it's nothing to do with thingamajig, cumulative frequency graphs, right? Different people, who can tell me where this bit of the box and whisker plot comes from? Paul? How do I get that figure there? Ellie? It's not the lower quartile. It's the lowest possible value, and vice versa, that is the highest possible value. What is the beginning of this box here? Where's it created, Abby? It is the lower quartile. Bringing it to the end of the box is the upper quartile, and this middle line here is the median. Okay, the line inside it is a median. And what is that telling you about a box plot, Ivan? Interquartile range. It's where 50% of data lies there. Okay, and that's how you create it. And you will need to compare and contrast it with, with something else looking like that. Okay, with another box plot looking like that, and just pull out various comparisons. You've got to have that skill. Anyway, the last thing we're doing is this. We're doing together. Don't need to get the question written down. You're going to help me. Okay. I hope you can kind of see that. Maybe I need to zoom in just a